Ionic size has a very similar trend to atomic size. In fact, down the group trend is essentially same as the atomic size. Let's look at lithium plus iron and sodium plus iron. So lithium plus iron has 2 electrons in its first electron shell, and that's it. Sodium ion has 2 electrons in the first electron shell and then 8 in the second electron shell. Essentially 1 electron shell difference. And same in fluorine ion and chloride ion. So ionic size increases down the group. Across the period, let's firstly look at group 1 to 3. So let's add boron here, which has 5 protons. So let's look at the ionization state of these 3. Lithium plus, beryllium 2 plus, and boron 3 plus. How many electrons do these 3 ions have? They all have 2 electrons, right? And then here we're seeing boron with the most number of protons, which means its nucleus will exert the strongest electrostatic pull on its electrons, meaning the first electron shell will be shrinked the most in boron, meaning boron ion will be smaller than beryllium and beryllium smaller than lithium. Okay, so I'm going to display this information on this graph. On this graph, I'm going to label lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. On the y-axis, we're going to call this the ionic size. So let's say lithium, beryllium, boron has this decrease in ionic size across 3 of them. Let's look at the nitrogen, oxygen, and fluorine. We're going to skip carbon because it could have gaining of 4 electrons or losing of 4 electrons to become an ion. Nitrogen has 7 protons, oxygen 8 protons, and fluorine 9 protons. Ionization state 3 minus because it gains 3 electrons to form the full shell, oxygen 2 minus, and fluoride ion 1 minus. Same number of electrons, they have 10, 2 from the first electron shell, 8 from the second electron shell. However, fluorine has the highest number of protons, and therefore it will have the fluoride nucleus will have the biggest pull on its electrons, meaning fluoride ion will be the smallest, oxygen being the next smallest. So we're seeing the same trend of ionic size decrease, but then let's put the trend a lot higher than the group 1 to 3, and that is because we need to bear in mind that these 2 groups of ions have what? They have a difference of 1 electron shell. So these groups will obviously be a lot bigger than the first group. Group 8, neon, we will not talk about this because they don't like being ionized. And why is that? That's because they're in group 8. They already have a full electron shell and are already very stable.